So use the exponent law, simplify. The first one I have x to the power of 3 times x to the power of 8. So I'm using which law? The product or the multiplication, right? So if I'm using that, what do I do with the exponent? Add. So that's going to be x 3 plus 8, which is x to the power of 11. If you don't want to show the middle step, that's fine, as long as your answer is correct. But for example, if you show me the middle step and then you do 3 plus 8, but then by mistake you wrote x to the power of 12, at least I know that you know what you're doing, and then you don't lose all the marks. But if you show me x to the power of 12, then I'm going to be like, yeah, no. Right? So there is a difference between, if you show me this step, let's say if this is out of 1, you'll get 0.5, right, out of 1. If you don't show me the middle step and then you wrote x to the power of 12, then I can't give you anything. Does that make sense to you guys? So in this case, what do I do? What law do I have? The multiplication, right? The power to the power. So I have to multiply the 2 times the 4. So that would be x to the power of 8. Okay, how about the next one? What law is it? The subtraction. So it's the quotient law, right? Which means I subtract the exponent. So that's 9 minus 3, and that would be x to the power of 6. For the next one, you see that basically what I have is x cubed y squared times x y 5 to the power of 5. So in this case, the brackets, they have nothing to do with, I can write this like this, right? I can write it like this because the brackets just mean multiplication, right? So I can technically remove the brackets, pretend that they don't exist. I have all multiplication here, so what do I do with the same like terms, like base? So I have these like base, the x. What do I do with their exponent? Add. And then for the y, I add. Okay? So you see that in this case, I'm taking the like base and I'm adding their exponent, the like base and I'm adding their exponent. So that gives me x to the power of 4, y to the power of 7. If there is no power, it's a power of 1. You don't have to. Try not to put times unless you really have to, because the times and the x, they look like alike, right? So you don't want to mess it up, okay? Or if you want to write your x's like the French x's. All right. It looks like this. Yeah, it's this one. You see me writing sometimes, like I sometimes write in the French way, sometimes. It's just because we're used to it. So sometimes we write the y like this, sometimes we write it like this, and then this. No. It's just because I learned too many languages. All right, so x to the power of 4 times x to the power of 6, y to the power of 3, right? They're all multiplied together here, so I can remove the bracket. This is the same thing as writing this, and this, right? Next to each other. A lot of you, and don't write this, please, a lot of you are mixing up between this and what we just saw. Okay? Oh, this doesn't want to write properly, right? These are not the same thing. You only distribute if you have a plus or a minus, okay? So, in this case, I only have x to the power of 4 times x to the power of 6 times y to the power of 3. So I add the like terms, so that's 4 plus 6, y to the power of 3. So that's going to be x to the power of 10, y to the power of 3. Are we okay with this? I personally, when it comes to division, I don't like to write that division. I like to write it as a fraction, okay? Because then I can see properly, especially when it comes to the numbers. So I personally, this is what I would do. This would be my first step. You don't have to follow my steps. So I write it first as a fraction, just so, especially when it comes to the numbers, to the coefficient, it's easier for me to see the coefficients, okay? So when it comes to the coefficient, I have only the number 2, right? This is basically 1 here, so that's going to stay as 2. Then I take the x's and I subtract the exponent. So that's going to be x 7 minus 6. And then I take the y's and I subtract the exponent. Right? So what I do here, so I can simplify, and you get 2x to the power of 1, which you don't need to write that power of 1. And then y to the power of 3. Are we okay with that? Is that clear for everyone? Which one do you have the most problem with or trouble with? E and F. It's going to get a little harder. All right. So let's move to the next part. All right. So there's 2 more rules that we're going to learn. Okay. The first rule is power of a product law. So if we had this, what did we do? So we multiplied the exponent, right? So it's y to the power of 6, 3 times 2. Yes? Now what if, instead of just y, I have x to the power of 4, and then y to the power of 3, all to the power of 2. What would I do then?
I add both of their exponent multiplied by 2.
So you're going to have to multiply that 4 by the 2 and that 3 by the 2, right? Can I simplify inside my bracket first? No, because they're not the same base. They're different base, so I can't simplify. Okay? So in this case, I have to distribute that exponent to both of the terms inside the bracket. Because think about it this way. If I'm going to expand this, right, I'm going to write this as x4, y3, and then times x4, y3, right? I'm going to write it twice, yes? You guys agree with that? Right? Because it's to the power of 2, right? This whole thing is to the power of 2, so I'm going to have to write it twice. So what happened here is that going to be x to the power of 8, y to the power of 6. Yes? Because I'm going to add my exponent. But if I don't want to do this step here, because I don't want to expand, I want to reduce as much time as I can, what I will do is that exponent here multiplies to everything inside the bracket. So it's going to be 4 times 2, so that's x8, and then y 3 times 2, that's 6. Okay? We are distributing our exponent in. So let me write the middle step here first, okay, which is the multiplication. Again, you can skip that middle step. And go right away to the last step. Do we get this? Do we understand what's happening here? So this would be this right here. So you see that the exponent here is multiplied into each term inside the bracket. Okay? So let's say if I had a b to the power of 4, c to the power of 2, all to the power of 3. What would that be? A to the power of 3, b to the power of 12, c to the power of 6. You see, this is power of 1 here, so you multiply each exponent by the 3. Do we get that?
Yeah.
Okay, I'm going to give you one more example. Let's look at this example here. Why is it 8?
Because it's 2 times 2 times 2.
What's the power on that 2? So this is part of your bracket, isn't it? Right? You can't leave it out. You cannot ignore it. Right? So this right here is also going to get that power of 3. So that's going to be 3 times 1 is 3. So that's going to be 2 to the power of 3. Then a to the power of 12. Then b to the power of 6. Now later on, when you're done distributing your power in, then you can punch this into the calculator. 2 to the power of 3 is 2 times 2 times 2, which gives you 8. A lot of students miss that part. They forget that that 2 also gets the power. Okay? So do not make that mistake.